All right, so we've declared, we decided to delegate the determination of the size that we need to grow. We've decided that we're going to delegate that to classes that are going to extend our implementation, right? That to decide different strategies on how is it they want to grow the character array. So we'll look at different strategies, different ways that we can expand the array, and then compare and contrast them as we decide different strategies, right? So instead of providing a single implementation, a single version of deciding right now what the strategy might be, right? Instead, we're going to declare it abstract, right? And we're going to create an abstract class that implements all the algorithms that we have so far, except this one method, right? And instead, we're going to leave many different strategies responsible for implementing the determining of the size, right? Everything else stays the same, right? We are still concatenating one single character at a time. Yes?
What if we use like a linked list or something so you wouldn't have to grow the list at all?
Well, we do want to, you still have to instantiate each node. You have to walk the tree, point to the end, right, and append to it. And then to build it, you have to iterate over it, right? So that might be an implementation. Perhaps we can consider that. We don't have a linked list implementation, but I think that would be interesting to add it as an option here. Yeah, that'd be a good idea. Yeah. And linked lists allow you to easily perhaps take two linked lists, right, and just tie together the end of one of the lists and the beginning of the other, right, without having to walk the list, right? So if you have the tail of one with the head of the other, the concatenation should be trivial. So you wouldn't probably have any of these issues so we wouldn't have the problem of the plus operator of concatenating, but we did want to have that problem to illustrate other operations that apply that solve the same issue, right? Right, so let's look at an abstract version of this, of implementing determine the new capacity. We'll look at 4 different versions of this. Let's so here's we're going to rename our original class where we were implementing all the resize, the ensure capacity, the append, the toString, all that. We're going to rename it, and it was a full class that we were working on. Instead, we're going to rename it abstract. We're going to put abstract in front of it, since indeed it's going to be an abstract class, and we're going to leave one of the methods unimplemented. But the implementation is the same, right? We have the contents as an array. We have the length. Perhaps we have an initial capacity. We are arbitrarily choosing it to be small, to be 10. We have the string value, that converts the array into a true string. We have the toString here. We have the initial implementation that we had earlier, right? That I want to have at least one additional character, at least one of those, so that I can copy over that one character. So basically, what we had earlier. The only difference is that we're going to leave the determining of the capacity, this one, right? The determine new capacity. We're going to leave that abstract, right? So we have this is what we have so far, right? We return the capacity. One thing here, notice that the length was made private, right? So that nobody can access it, right? So that even our children, we made it final, so that even our children cannot inherit from this length. So we needed to export it through a public interface, so that even our children needed to access it through the capacity, right? We don't want the child somehow mocking around with the length, and we want to make sure that whatever the characters are in the array, the length also tells us exactly where that character ends, right? That we don't have an inconsistency of the characters that we mean and the length pointing to that last character. Yes, that's an invariant. That we want to make sure that those two representations are always meaningful, right? And we don't want to let any child override their parents. So here's ensured capacity. Right, it's the same implementation as before. Right, it delegates to the determined new capacity to decide whether I should grow or not. So it's what we have so far, right? The only difference here is that we are declaring our determined new capacity as abstract. Right? We're not implementing it. Right? We're delegating that implementation to our children, who are going to decide different strategies. And here's where the crux of the whether this will be performant or not. Right? Whether it'll be our implementation will outperform our previous attempts. Okay. All right. So let's look at our first one. We'll try and implement. First, we'll look at at a trivial implementation. All our versions of our strategies are all going to extend this abstract array string accumulator, right? And they're going to inherit all their methods. They're not going to override them, right? The only thing that they're going to focus on is implementing that one determined size, right? That's all they're going to do, and that's the only thing that they're going to be different, right? We're going to first look at a trivial version, right? That basically performs as bad as a naive solution, right? And that kind of gives us some confidence that our new implementation mirrors, right, what's really happening underneath, right? The underlying the default implementation. We'll look at that first, and then we'll make tweaks as we go. Right? Also, yeah. So here we added the capacity as protected final. Final that we're not letting the children mess around with any invariance because of inheritance. Yes. All right. So let's take a look at 4 strategies.